So it's an absolutely fantastic privilege of me to introduce our fantastic panellists. So I'll start from this end. Professor Prokar Dasgupta, and I've got it written down so I don't get it wrong for all of the esteemed titles, but you're the Professor of Surgery and Chair in Robotic Surgery and Urological Innovation at King's College London, and a consultant urologist at Guy's Hospital, which is where we are right now. He's also chair of Responsible AI's UK Health and Social Care Working Group, and his main interest is in the immunology of prostate cancer, and he's part of the Prostate Cancer Research Centre at King's. So welcome, Prokar. And sat next to Prokar is Professor Elvira Perez Vallejo. Is Professor of Digital Technology for Mental Health in the Faculty of Science at the University of Nottingham. And she's also the chair of the Equities Pillar at Responsible AI UK. So I'm sure we'll get some very interesting questions and discussion about that. So welcome, Elvira. And next to Elvira is Professor Anita Grigoriadis, and Anita is a Professor of Molecular and Digital Pathology in the Faculty of Life Sciences and Medicine, King's College London. She's an executive committee member and the training lead of the Cancer Research UK City of London Centre and heads the cancer bioinformatics teams. And as we'll get into the questions, very excitingly, she recently received a very large funding award from the UK government to establish what we call Pharos AI. I'm sure we'll get into what that is. So welcome, Anita. And last but not least, Pankaj Chandak, paediatric transplant fellow at Guy's, also Great Ormond Street, and Evelina Children's Hospital, postdoctoral research fellow at King's College London, and the UCL Institute of Child Health, and also the Hunterian Professor at the Royal College of Surgeons of England. And his research interests include machine perfusion of organs and innovations with therapeutic interventions, bioengineering, repair, and regeneration. Welcome, Pankaj. So, I'm going to take chair's privilege and start with some questions of my own before I go to your questions, if that's okay. And the first one to Prokar, if that's okay. So if you grab a microphone. And my question is, you're Professor of Robotic Surgery, as I've just said, and a pioneer, a real pioneer in robotic urological surgery. And in sci-fi, we often see robot doctors and surgeons, I'm thinking Star Trek here, who seem to have replaced human surgeons. How realistic is that future? Prokar.
The short answer, Graham, is not at all realistic.
Okay.
And in fact, it's not going to happen in my lifetime, or I hope it will not happen in my lifetime. With the pace of things, anything can happen, but I don't think it will happen. So let me give you a little example to make it real. We have in surgery something called levels of automation. It goes from 0 to 5. Okay? 0 is no automation. 5 is fully automated, where the machine does all the work. So I brought something to show you today. So, fishing in my pocket. So this is a completely automated 3D printed prostate. In fact, Pankaj is the pioneer of this. He designed the first such 3D printed organ. In fact, it was a kidney. So this is a real patient's 3D printed prostate. And for those of you who don't know, the prostate sits here. Yeah? So if it gets a cancer, we put 6 small holes in the tummy, attach a robot, and remove this. But it is controlled by me or the surgeon. So that is level 1 automation. If this gland becomes big, then we can make a hole in the center of it. And in order to make that hole, boring the inside of an apple so that you can pee better through the hole, you can design that hole with ultrasound, press a button, and a machine will create that channel. That machine exists today, and it is the most automated, but that is level 3. So it's still planned by a human being. So the answer to your question, it won't happen in my lifetime. Level 4 and 5 automation will not happen.
Thank you very much. So if you pass the microphone on to Anita, I'm going to come to you second. And you, as I mentioned, you recently received a large grant from the UK government to establish Pharos AI, which aims to be a catalyst for AI models in healthcare and research with a focus on cancer care. So what do you see as the greatest opportunity for the use of AI in cancer research and care from your position?
Thank you very much. So for those who may not have heard of Pharos AI, it's an initiative that was recently funded by the Department of Science, Innovation, Technology. We received just below 19 million and we raised around 25 million to establish an ecosystem where on one side we can bring our research biobanks into the 21st century. So we explore lots of research data from, cancer patients, this molecular profiling, medical imaging, and really good clinical data. And we, on the other side, create a platform where we can host this data. So researchers like you can come in and can build AI models. You can bring your AI models and test these AI models, but also industry can come in. And the data always stays here with us. So the data does not leave the trust and our trusted research environment. So this gives us now the opportunity to test AI models. So for sure you have, I guess all of us hear all the time, oh, here's a new AI model that can do this and can detect and biomarkers here. But truly ask how many AI models end up at the hands of our clinicians. Hardly anything. Because they cannot be tested, we can test the development, the deployment. So this is where Pharos really hopefully initiates and ignites a whole ecosystem where AI-assisted tools can be tested and the deployment can be then tested. So that's where I really see where we can help with the AI in cancer care.
Fantastic. So Pankaj, so we'll come to you at the end, Elvira. As an expert in transplantation sciences, what do you think are the biggest opportunities of AI in this area?
Great. Well, thank you, Professor Lord, and thanks to Catherine for the invitation to join this esteemed panel. So in transplantation, which is the replacement of tissues or organs which are functioning for a patient that needs it, is quite a vast field. But in terms of, if I try and break down sort of the basic principles of what I think AI can contribute, the first really is in matching donors to recipients. So we use complex algorithms already to make that matching process better, so recipients have a shorter time on the waiting list. But then if we go further, AI is also used to now assess organ viability. So some of the research that I do is if I get a human organ and I place it on a bypass machine perfusion, essentially, and you connect it to blood-based solutions, that organ will start to function. So if I get a heart, it'll start to beat. If I get a kidney, it'll start to make urine, or the liver might start to make bile. And that gives us real-time data about how that organ is functioning, and that can be fed into algorithms to predict longevity of that organ. So that's quite exciting work. And the other way we can use it is to enhance surgical planning. So one of the most complex transplants we do is to place an adult organ into a baby, into a small child. And sometimes we can't be sure of the feasibility of that operation. So we can use AI and 3D printing that you saw for automation and better segmentation of these images, which are less subject to variability if a human being was going to do it. But I think the last area is quite exciting. I also work at the interface between clinical medicine and basic research. So bioengineering a whole new organ and using AI for that is quite exciting. So AlphaFold won the Nobel Prize this year.
Can you turn up the volume,
Can you turn up the volume a little bit, please?
Leave it to the AI guys.
It's so hard to hear. Sorry.
No, fine. Well, thank you for saying it.
Is it reverb, is it? Do I sound like Beyonce? But essentially, what I was saying was bioengineering.
Is that better? Good.
And using tools like, we spoke about tools like AlphaFold, which won the Nobel Prize this year in chemistry, can predict protein structures. And then if we can predict how proteins are structured, we may be able to predict how cells interact. and therefore we can design better organs, better blood vessels, and predict the longevity of those scaffolds. So I think that's going to be really exciting in bioengineering.
Brilliant. Thank you, Pankaj. Elvira. So as I mentioned in my introduction, your work focuses on mental health.
Yes.
As we see the rise of AI-powered chatbots in this space, acting as mentors or therapists, what issues or concerns do we need to keep in mind?
So currently, maybe some of you have used chatbots to check how you were feeling today. Maybe you're feeling a bit down. And the answers you may get are sometimes quite sympathetic. They usually signpost you to services. If you play around and you pretend you are worse than you are, it will really tell you go and see your GP. So that's okay. However, this is text-based. And this chatbot doesn't know if you are crying, doesn't know how you really are. So in terms of detecting emotion, you need a camera, and you need a more sophisticated way to, for example, analyze your voice. All the linguistic cues, the paralinguistic cues, the prosody, the poses, the intonation, chatbots don't have a clue. Therefore, I feel we are at the very beginning of something that can be very exciting. But right now, chatbots are emotionally non-intelligent, and therefore, if you bring that tool into the mental health arena, you're bringing a tool that is ill-prepared, because mental health, emotions, how you feel, how you experience, how you construct meaning is definitely, is the basis. So in Nottingham, we're actually training a grief bot, and you may think, why grief? Well, grief and loss is an emotion that we all experience. It's not a pathology. It becomes a pathology after 6 months. But grief is related to anxiety, to depression, even psychosis. So we thought it could be a nice preventative tool for those we all experience grief and loss. And interestingly, our research participants, what they are saying is we need a cultural adaptation. Grief, I'm Spanish, the way the rituals, the funerals is so different in the UK, in Ireland. But also what is very important again is the linguistic expression of grief. And I think once we sort that, the cultural adaptation and also if the chatbot talks to you and you can talk to them, that's when we will have a tool that actually can be quite interesting and effective.
Fantastic. Brilliant series of answers. So I'm going to turn to some questions and answers from the audience. But I'll answer them before I open it out to the audience, if that's okay. So we've got a question submitted by Celine M. I don't know if Celine's in the room. If you are, wave. If not, I'll ask you a question anyway. And her question is, how accurate can AI be when helping with diagnostics and treatment? And how can its accuracy be improved? So which one of you wants to pick that up first? Anita.
I can start. So how accurate can an AI tool be? And it can be very accurate, yeah, I think. But and I guess the question is, when you have a diagnostic tool, can it, right now, quite often the first AI tools that are coming out are built on one modality. What we need to think is that if you think of an MDT, there are many clinicians sitting and giving information. So right now, there are lots of tool development out there that try to pull in different modalities together. But again, the clinicians, when they sit around, they discuss and weigh up the different modalities, and it's their experience that knows what weighs more than the other. So again, there are now models, concept bottlenecks, how they called, that can in a way evaluate, how these different modalities all influence. So will there be a chance that there is an increase of accuracy? Yes, there is. Will it be the final decision? I don't think the AI will give you the final decision.
Fantastic. Does anyone else want to add? Burko.
I think the accuracy can be increased by diverse data and by transparency of that data. I think these are vital. Let me give you an example. Our colleagues in the Netherlands put out many biopsies that were taken from real patients, anonymized, of the prostate gland, and put these on a platform which was available open source to everyone. And programmers from different parts of the world started writing programs to see if they could diagnose the cancer. And in 3 out of 4 such programs created, they were as good or better than the doctor. Yeah. But this shows that you can take something like this, make it diverse, involve different people from different parts of the world, and get excellent results. This is what builds the public's trust in this kind of diagnostics. So I think this is vital of what the data is, whether it's diverse and whether it's transparent.
Okay, well, so if you keep hold of that, because then we can go back down the line. But the next question submitted by Evan H. To what extent should AI-driven diagnostic systems be allowed to override the clinical judgment of NHS physicians or surgeons, particularly where the AI's recommendations contradict human expertise, but may have statistically demonstrated higher accuracy in similar cases?
I'll hand over to Evelina.
Now the questions are getting hard. Elvira. Great question, by the way.
So my gut instinct would say, of course, the clinician, the human, at this point in history, of AI history, it should always have a say. However, the last bit is the confusing bit. So you're talking about a system that is very accurate. So are we comparing an extremely accurate system to a really bad physician? I will need to see, the context is missing a lot of information, but in principle, right now, a machine should never override human judgment in medical care. That's my opinion.
Yeah, I also found this question quite interesting with the emphasis on statistical significance, because I guess maybe some of you all know, a p-value may be a p-value, but does it give you the overall picture of a patient, the emotions probably, So I think we're gonna be here, I think it will be a long path before we let an AI model override a clinical decision.
Pankaj.
Yeah, I mean, I absolutely agree. I think that the human being should be at the end chain of any of these AI tools, actually. As a surgeon, I'm speaking as well. I think Prof would agree that we can rely on the tools to give us information, and we should be using them, provided they're validated, accurate, and accepted. But the end decision-making should be the clinical team. So even if they are predicting things possibly faster and more, in terms of sensitivity and specificity, but that evaluation should be done by the human at the end to decide if they're going to use that information for a clinical decision, I think.
I guess as a sort of follow-up question for me around that, we've been discussing this quite recently about when AI or digital systems become potentially standard of care and how that's going to get driven through. And we don't necessarily need to answer that. One of my concerns here, particularly if AI is accessible to patients and they're actually using AI on their own data, and that makes a diagnosis that a physician or a surgeon misses, where does the liability sit, particularly if there's a delay in diagnosis? And I just wonder whether standard of care and the legal profession will drive the adoption of AI as much as clinical judgment. Maybe it's a question, we can come back to that about the legal framework and the regulatory framework as we get towards the end of the session, if there's time. If not, I'll just leave that one hanging, because it's important that we get audience questions rather than mine. I can talk to them in the bar afterwards. So following on, submitted by Maria L. How do we enable timely integration of AI whilst ensuring we maintain a secure environment? I don't know, Anita, do you want to pick, because you're obviously dealing with this right now with Pharos AI, right?
So actually, you know, as we all know, our infrastructure is quite clumsy and complex. And while these AI models are coming on the market, quite often the back end to bring them to our clinician doesn't exist yet. So we have to do a lot of workup, you know, in parallel while we keep working on AI models and accuracy, but also we need to help our NHS and our hospitals to make their data, their system, the LIMS system, you just enable this. So there is a lag, I think, in these next years that AI is there and could be used, but we need quite an injection also in the, you know, to make the infrastructure ready for AI. Yeah? And I think that's where we're a little bit, where the imbalance is.
So again, very interesting questions. To me, the interesting point is that balance between privacy and security and innovation. And I'll give you an example. A GP came to university and said, I have this problem. I own different GP practices, and I just want a very simple solution that looks, before I see the patient, this AI system looks at maybe all the tests, all the results, and just flag what's important. Don't make me go through hours and hours of looking at negative tests, because that doesn't bring any information. I thought, how easy that could be, and how much time I'm going to save to these several GP practices. It was impossible, because each test comes in a completely different format, and you need different barriers to access that specific result. And that format may change depending if it's coming from one hospital or another hospital, or one lab or another lab. And then the solution is not as reliable as it should be for this GP to blindly just hope that this AI system is going to flag what's important. So we couldn't do it, and it's such a simple solution that could save potentially lots of time. So the data infrastructure is very problematic.
Yes, and I suspect some of our politicians might think that's a great idea, but the reality of our disaggregated data systems and formatting, unfortunately, is the real world that we all live in. So, but that's a great example, actually. It's a great example. Okay, so actually this may be one for you to kick off on next, Elvira, as well. Submitted by Anna B. So do the panel think that having empathetic AI agents is a vital part of future healthcare AI? So maybe you want to start with that.
Yes. The answer is, so empathy is a very unique human quality.
Yes.
Active listening, the way you engage, your body language is so important to connect with that person, so that person can disclose how they feel something. It's so important for this alliance, this rapport, clinician, patient, or clinician, user, is crucial, and I think the same should be translated into AI. We have the beginning of very empathic but very repetitive expressions of empathy. The first time you read it is interesting, but when the same expression appears 5 times, it's not authentic. So to me, the question is, how do we create empathy that is genuine and it touches our hearts in the same way a genuine empathic human response could do?
Yeah, good answer. I don't know, surgeons are obviously known for their empathy, and I can say that because I've known him for 25 years, so I'm not being rude, but you know what I mean. Pro-card, empathetic AI agents, come on. Sorry.
Colleagues in Japan, particularly with the elderly who face isolation and loneliness,
Yes.
have had robotic tools, full-fledged robots, which smile, which respond, and provide that empathy when there is no one to look after these elderly people. That being said, I don't think anyone does empathy better than a human being. So in my dying days, I hope to be able to speak to a human being. If not, I'll just, like a surgeon, shut up and die. I mean, I don't want to speak to one of these machines. That's me. I do not think empathy will be replaced by machines. It's just not good enough. Otherwise, everyone would have imported these machines from Japan. I haven't.
It's an interesting area. I mean, we have a project going on at the moment with our robotics department on the Strand, actually, to work with our paediatric oncologists at the Evelina Hospital to have some empathetic teddy bears that can listen and then respond in a way. So I don't think it will necessarily replace that, but it's potentially an additional piece. We'll come to the audience in a second. Yeah, I know you're all itching to get in. I'll get through a few of these questions. One more, and then I'll open it up, and then I can come back depending on the audience, because the people are trying to catch my eye and wave their fingers. In fact, why don't we, let's do some roving questions, because we'll keep one for the panel, and if we do a roving question. So did you have your hand up as well? On the front row here. Did you have your hand up? Yeah, we'll come to you afterwards. So go on, ask a best question.
Because you're talking about empathy, and I think you're talking about chatbot. Perhaps the chatbot does not have all the information that perhaps ChatGPT holds. Because when I have long conversations with ChatGPT, it's really empathetic in a way it communicates, because I think one of the things about being empathetic, it's really listening to what the person is saying, and it also repeats what I'm saying to make sure I was understood. And I'm very good in communicating, so I know how you have to talk to people, and one of the things you really have to listen. And sometimes you even use the same words the person said. You repeat to that person, so that person acknowledges that you are listening. So AI is great for that, I think. And I think it has developed a lot, and it's, come on, I know you can do it, and it's encouraging to see. I'm not saying it's going to replace, but I think for initial screening or certain things, I think it can be useful. But of course, nothing will replace the love and the connection we have, the energy, especially the energy I think human beings exchange. Sorry, I just wanted to
No.
that
I think, I don't know if anyone wants to come in on, it's almost a philosophical point, a bit like the Turing test. Can AI, if empathy is such a human characteristic, can AI be empathetic? I mean, it's almost a bit philosophical, isn't it? It's like, do androids dream of electric sheep sort of thing? So I'm not proposing that we open that up for the next hour, but it's a very interesting question, actually, that I think we're at the start of trying to get some data to answer that. And I guess in part it's how you define the response to it as well, and when does that response wane, and how does it react to that in real time?
And I think very soon it will be hard to distinguish a multimodal bot where you imagine a screen with an avatar that you don't know if it's a person or it's and the way they will talk and the mistakes, they will, for them to look human, every now and then there's a random mistake that will, what's coming is amazing. But again, it's how much responsible development we put into that to ensure that people don't get manipulated, there's no additional harms. But what's coming to me is quite spectacular.
Brilliant.
I have actually two things to say. One is related to this topic, and other is completely different.
Fine.
So may I
Go for it, please
continue with this topic?
Yeah.
So I remember I've read somewhere, by the Melexenko University of Surrey. I've read some study, or maybe in popular literature, that if some actor is too human-like, and we know it's not human-like, then people are scared. So AI, as you described it, especially in mental should behave human-like, but won't it be a problem when it becomes too human-like to start scaring people? So this is my first question.
Okay.
So if you mind,
So and I guess maybe this is linking into some of the work, particularly is going on at the Institute of Psychiatry, about avatar therapy potentially, in terms of a therapeutic intervention that we're actually doing testing out in real time. But what do you think about that?
So the benefits are that you can adapt in real time how this avatar or this AI therapist interacts with the patient, and it will give you preferences on what is it that you want, what is it specifically working for you now. And that's an amazing advantage, because usually we go either for a style or school of therapy, but we don't try 5 at the same time, but we could have an AI therapist that knows that today this strategy or this tool will work. To me, that's amazing. But then we need always actually there should be transparency. You should always, as a user, know if you are talking with AI or not. That's let's say, a human rights. Otherwise, the level of manipulation can be. But also there are some specific conditions where that's even more when there are delusions or paranoias, or that needs to be extremely, extremely transparent. We've done some, again, going back to grief, some user testing, and many people wanted their religion to be represented, even spirituality, and very personal, very unique ways to engage with the concept of death and dying. And there are so many libraries, so much text, so LLMs are fantastic for that. So you can ask, and even ChatGPT, you can ask for any specific view in terms of religion or world views, and it will be quite interesting. It's English, so now what we are doing, you mentioned diversity of data, we're looking at any other language or culture, so how can we ensure that covers and caters for everybody? But it's quite, right now it's pretty good, but what's coming, I think, is going to be much better.
Your second question.
yeah, thank you very much. So maybe switch to something completely different?
Please.
Okay. Suppose, I attended yesterday event, and during this event, someone mentioned that the artificial intelligence model, which was 99.9% accurate, was still not approved for medical use. So this answers the previous question, actually, how accurate they can be. So suppose there is a scientist who works in stroke prevention, can prevent 30,000 strokes a year, and there is an option, get to 95% and have NI, artificial intelligence component, or slightly less, but no artificial intelligence. So what do you think, what the optimum strategy would be? And maybe there is a need to take some action in, I would say, political space to move towards easy approval of AI-based algorithms.
Prokop, we were discussing this briefly before the panel, weren't we? About
Yes,
accuracy.
yes,
Yeah.
yes, we were. Thank you.
Yeah.
Very, very important question. So if we are to stop being a talking shop and actually do something for the public, then we need to move it from the lab to actually implement it. If you gave me something that was 99% accurate, I can tell you the regulatory body, which is the MHRA, would happily accept it. How do I know? We convened a meeting on behalf of Responsible AI at the London Institute for Healthcare Engineering. I think that's what you're referring to yesterday. And this included government ministers, big tech, doctors, regulators, procurement, patient safety representatives, and patients. So all the right people. And this was a group of doers I put to them that we needed to stop these queues of ambulances outside casualty rather than talk shop. I didn't want to have even more talk about nonsense. And the regulator said that if there were 10 devices which were 90% accurate, they would hack 9 of them and make the best one as accurate as possible, above 90%. And that would be acceptable to patient representatives. So that leaves about 5%, and you can see the Guardian headlines, AI killed my dad because it made the wrong diagnosis. The companies are saying they are expecting to be sued, yep, but they can defend it. No human being is perfect, no machine will be perfect, there will be lawsuits, but they can defend it. That is fine by me, and I think that's the way to go. Rather than keep talking for the next 10 years while we become the butt of jokes, international jokes, with people waiting 10 hours in casualty. There was someone in that room who said, I have a platform which can take away 50% of the patients from those ambulances. So they are currently talking to the Chief Secretary to West Streeting on the 3rd of June, because I want some action to happen and not keep talking. I'm fed up of talking, actually.
Oh, well, shut up then.
Not here, not here.
No, I'm joking.
Not here.
No, you're very right. I don't know if anyone else has a... Fine. Okay, please go.
okay,
And then
cool.
yes, okay, good. Then we'll come to you.
So I've swapped out my question to keep the theme going on this particular topic. So quite recently we had Skin Analytics, which is, I think it's the first UK company, maybe not the world's first company, but certainly the first UK company to get a Class 3C AI as medical device certification. Given the initial, when I came back to medical research 7 years ago, obviously people were very conservative about the use of AI and how it might affect diagnosis and so on, and that's shifted over the last 7 years. Do you think with this first of this Class 3 certification, are we enabling a bright new dawn, or are we opening Pandora's box?
I'll be brief. We are opening new doors. I see healthcare AI in 2 categories. Process AI, someone mentioned notes, and easing the way so that we actually talk and listen to patients rather than type on the computer, and the patient sends a complaint saying, the surgeon never looked at me, he was typing on a computer. So process AI, there are already programs like that, such as Tortoise. And then what you are saying, patient-facing AI, that's the second category. And I think more approvals is good for patients.
Fantastic. Question at the back. I think we're just waiting for the mic. Let's all test our ability to coordinate.
Thank you. The best health system outcomes in the world include Singapore, UAE, Saudi Arabia, and Germany. They're already using AI, they're already using analytics, and already using machine learning. Vision 2030 in Saudi Arabia, there's going to be $1.8 billion investment. Why don't we just use SAP IS Health Solution?
I don't know who wants to answer that. That sounds like a particular specific question we might not have the expertise on the panel to address. We'll come back to you on that. We'll find out and come back. No, I think that's a very specific question that we probably don't have the right people here to address right now. Are there any other questions from the audience whilst we're... There's 2 up at the back. So right at the back first, and then 3 rows down. We've only got 1 roving mic, so we'll come to you afterwards. At the back. Oops, has the battery run out? Thank you.
Thank you so much. Thanks so much for all the insightful observations. Really, really exciting to see all the work you're doing, especially with that Pharos AI. We'll keep an eye on that. I'm here with my daughter, Maya, who's an A-level student, and she's got an essay, an EPQ essay to write, and the topic is AI in neurology. So if you could just help us talk about, possibly maybe about Alzheimer's or dementia, and how AI is being used in any of those diseases, or you could keep it broad. That would be really, really helpful. Thank you.
Okay.
Well, I know a little bit.
Yeah.
So I think the most successful practices in AI in this is for the diagnosis. So instead of asking the patient to complete lots of questionnaires that traditionally are paper-based, or do tasks that are manual, maybe cognitive tasks, or to put dexterity tasks. So there is a translation on the online. So it seems they can do it at home, in their own time. So it seems to be more friendly. There are also ways to monitor, again, with sensors, with tech, if the progression, how fast or how slow the progression is going. So there are a few things there, but still there is no cure, and it's about supporting the person to live with the symptoms and obviously contain the symptoms as much as possible.
So to add a bit of something to that, Maya, there was a very good study within the last 3 months from UK Biobank where lots of companies have put funding in, 500,000 people. I think they did 50,000 brain scans, MRI scans, and applied generative AI to look for, and then they've obviously tracked the biobank population over the last 20 or 30 years. And so people are starting to get Alzheimer's disease, for example, as well as prostate cancer and other diseases. But the question was about Alzheimer's specifically, and using machine learning algorithms about what are the early signs when you do multiple image analysis to detect early signs. Now, there are also multiple AI tools that are able to try and detect early signs of Alzheimer's disease, not by an MRI scan, but sort of handwriting tests that are being rolled out as well. So, you know, why do we care about early diagnosis? Well, but actually because there are some treatments that are coming online, some of which are approved. You know, efficacy is not great, but it's a start, you know, mostly the anti-tau type drugs. And actually what's very, very clear is that the earlier you get the diagnosis, in fact, that's the only place it's effective, these will get better. So actually it's absolutely critical to get that early diagnosis. And actually AI, not necessarily in terms of the therapeutic, although with AlphaFold there are better ways of developing, you know, antibodies targeting things like tau, which I know DeepMind, AlphaFold are doing right now. But actually this is being used in real time. So I guess if you're writing an essay, 3 big topics, you know, biobank, you know, drug discovery, but then also digital tech and AI to detect it using non-scanning type technology. So hopefully that's helpful, and you can give us all the credit on the end of your essay. Yeah. There's a question a bit further down, this lady here.
Hi, thank you. I'd love to hear what the panel thinks about how AI in healthcare may help or hinder with social equity of care.
Great question. Social equity, help or hinder? Elvira, do you want to pick that up? Because this is your space, right?
In principle, AI could bring justice, and it could provide care in a way that is maybe supporting those that need it the most. And health, we know that social and where you live, it has a very important, so the specific areas could perceive more to get that equity input. How it's working right now, I don't see signs that we're going in that direction. What I see is massive companies, the 5 ones that everybody knows, creating the health solutions that, again, is attracting lots of investment, and some hospitals will be able to buy these solutions, others not. Right now, I don't have a very positive, there's so much work to do in terms of equity, and I don't think right now we are thinking, when we're thinking about AI in healthcare, that's not our main priority, should be, but it's not.
Anita?
So I think I'm taking a little bit more of a positive spin to this.
Good.
Because, so the way, at least in my field of diagnosis, yeah, so, you know, as you know, we have more and more technology and, you know, fancy diagnostic tools that actually are very expensive. And they take a long time. Some of the breast cancer tests, they are sent to a company, they cost thousands of pounds, and we can use them here, but they can't be used in other countries. Huh? But what we're doing now with AI, we can actually use this information, bring it back to a tissue slice, and that can then, we can use that for diagnosis, which means this is very cheap, because it's less than a pound, and this diagnosis can then be done in countries, and they're doing it. So in a way, we can help, to go back to quite basic diagnostic tools, because we can use this very rich information that some countries or some places can create, can bring it back to a simple tool, diagnostic tool. And so I think, in the long run, we will be able to contribute, I hope.
Good. So a risk and a benefit, and we need Prokop.
The word to me with equity is responsibility. Yep. And what she hasn't told you is that Responsible AI UK and the version before it, which was called Trustworthy Autonomous Systems, has produced through her these amazing responsible research and innovation cards. If you haven't seen them, go onto the website and look at it. And I think they are one of the best outputs that we have had to make sure we have responsibility and equity when we do AI work, not just now, but for the future. Amazing cards. Isn't that right?
Yes, I thought you might agree. Go and have a look. Are there any other questions from the audience? Was there? Yes? Please.
Hi, this is for Professor Alvera. My name is Shruti. I actually work with KCL Social AI Lab. We're actually developing a robot, empathetic robot, for mental health of children. We've actually done the perception part where we can perceive the child's emotional states, and now we're sort of processing how we would respond to that. That's where we're at. I would love to discuss that with you. My question actually is more towards the other side, actually. Amazon recently, no, I don't think it's recent, but they were discussing how they would develop Alexa in the voices of people who've expired. This is in reference to your grief bot. So they're trying to develop Alexa, which can talk to you in somebody who's expired, the voice in somebody who's expired. I just wanted to know your thoughts on that.
Great question. Gosh, sounds a bit scary. But...
So you're describing that Amazon can clone the voice of a person that is no longer with us. And yes, yes. So when we do these type of things, we are doing a social experiment. And my prediction is that as many experiments we do with no control or no ethics or no, just see what happens, there will be a small group that will get harmed. Maybe there is a dependency, is triggering, it doesn't suit them. There will be another small group that actually will benefit a lot. It will create, I don't know, some bonds that are healthy, and maybe the sense of loss is not there anymore. There will be a small group that will benefit, and the rest, it will be nifunifa, nothing significant. It will be a bit of a game or a tool or something exciting at the beginning, and it will fade, but it will not have a profound change in their realities, in their lives. To me, what worries me is that a small group that actually will get seriously harmed. And I think it's unethical to deploy something out there that is going to actually harm some people unintentionally. But this is why, again, we have to do this responsible research and innovation to ensure that we minimize harm in society. And also, there are many elements that we cannot even think about it that may happen. And to me, that's, again, a very interesting. We don't know, who knows, maybe in 3 or 4 year times, there's no such thing, well, not 3, but maybe in 100 years time, there is no grief because we have our robots that look like our grandparents living with us. And they talk like them, and they say things they used to say, and we have all this data. Our children are accumulating so much high fidelity data that it's so easy to create avatars of them, and this is happening. So we don't know how this type of death tech technology is going to engage, and it's going to change our concept of death and dying. We don't know, and to me that's very unethical. So great for Amazon. Maybe some people buy, and it's fantastic for them, but I worry always for those that may be harmed.
Interesting question and great answer. And I'm sure you can carry on talking about it in drinks in a few minutes.
Hi, thank you very much, medical student from King's. I think it's quite good to have all the panelists unanimously voting that a clinician should not be overwritten by AI in terms of diagnosis, isn't it? 4 of you have voted no. But I think on the flip side, most of our patients will also think about sensitive information, like the personal diagnosis, images, and sensitive areas. They'll probably unanimously say, no, I do not want my images or things to be used for AI. So in this day and age, how can we actually steward the use of sensitive images, photographs, even free text that we use in our clinical letters that have our nuances about certain diagnoses? And how can we actually still use AI in this tech context?
Go on over again.
So yeah, I think you're completely right. Data security, patient data security is huge, and while we're trying to, a lot of data that we're working is anonymized, pseudo-anonymized, through research banks, but there is also a research streams, cybersecurity, and we all heard about Marks and Spencer's, I guess, the last couple of days, or Synovis, last June, probably was for all quite a, shock, So it does happen, I think, but there is huge research going on to be able to, be as secure as we can to the current knowledge. And, the aim for all of us and is to be, have as many layers of governance, and actually working with governance, what is allowed and what we can do is really, really important. So I think that's a key thing for all of us.
What I was trying to point out was that patient does not have the option to opt out if we do have all this embedded within our healthcare records or healthcare system. It's not easy for them to say, no, I do not want my things to be used for AI, or do not put it into the AI system.
Well, yes and no. I think the governance is here to govern what can be put onto some platforms or not. So,
I think there's a question at the back. Is there a question back over there? No? Or if there's a question over here, if there's not one at the back. We've got a mic here. You're doing very well with the mic, so thank you for running around like that. And then I'll come back here.
Thank you. Can you hear me?
Yep.
First of all, thank you, King's College, for hosting such events. I have been here for yesterday. There was another event about AI in mental health care and all. So my question is, first of all, I'm Amit. I'm from University of Westminster. I'm doing data science over here. In my curriculum, I have an assignment about the breast cancer to predict, to make an AI model to predict the breast cancer and all. So past few weeks, I was doing my research about that, there's a tumor, so we analyze some, variables about how big the tumor is, how close is it near the lymph node. And the fun part is, while attending this event, I was researching about the panelists over here, and then I found about Anita, you have already made the AI model about that you have said, to predict the spread of triple negative breast cancer by analysis of immune response in the lymph nodes, which makes much more sense to me after doing my research on it. So I just wanted to know about this. How did you work on this? What was the entire procedure? Secondly, how do you envision integrating these tools to make the best patient experience and all?
Yep. Sounds like one for you, Anita. Breast cancer integration.
I can talk for another hour. I think we wait when we have the drinks, and I can tell you more about this. So it gives, data for a data scientist. Now it's data heaven, and with AI on top of it, it's really, as I said, we can talk a lot about it afterwards. But for the researchers, the students, there are great opportunities from governance to AI models to how we utilize things. Generative AI wasn't touched at all in this last hour. So, what actually questions could AI pose to us, yeah, with the data and the learning it does. And I think that will be also a very interesting area, that hypotheses will be created by AI, and we will then wonder, is this true and how can we validate this? Just exciting times ahead.
Good. You've been very patient waiting to come back in.
So I'd like to indulge myself with the second question, and this is my original one actually. So it's coming back on what you were just talking about with data. Yes, we have these amazing ethics agreements now that are getting put in place, which gives us access potentially to whole hospital data sets. But then we have a problem, which is we actually don't have enough GPUs and compute resource or the funding necessarily to be able to build models that you could potentially build with, you know, 1.5 million MRI volumes, for example. So strategically, what can we as a large university or, you know, even as a consortium of universities do to make sure that programs like JADE or JADE2 that actually provided good compute, that we have something more permanent as a solution to be able to do this size of data science in medicine?
Well, you go, and then actually, you go, Anita, and then Pankaj. But actually, what I'd like to come back to is the imaging, because I think a lot of the, as you said, a lot of the imaging data is very, very GPU heavy, as well as where do you store it. So maybe I can come to you. But Anita, why don't you talk about the biobank, because you've got to have a huge amount of data.
So we are, you know, the question. So one of the initiatives, you know, through FAROS AI is to create platforms where we can host foundation models, you know, in a way where we try to democratize AI. You know, how to use it to fund it, but also thinking how it will go ahead. You know, there are universities, Edinburgh, for example, are really strong and working on how to actually make computers more efficient, because we can't keep having these farms, that will, you know, that we will need to create this computer power, because otherwise, you know, whole districts will disappear because we need all this as computer farms. So there are also studies there how to how we make our computers more efficient.
So look, you asked me about the images, and I'll answer this in two ways. 80% of healthcare AI today is radiology. 80%. And that is images. Why? Because the PACS systems can store large amounts of data and compress them. You may say, well, why don't the pathologists do it? Because they are looking at biopsies. Why not take images of these biopsies? They just don't. The pixels just increase the amount of storage by many million times. So trying to then have these servers on cloud-based systems which can store these thousands and millions of pathology slides is very difficult, which is why this hasn't happened. But, you know, let me say this. On the data front, just 2 weeks ago, we had a senior scientist from Google address Responsible AI UK. This person used to be my PhD student 15 years ago. He was one of the brightest minds. No wonder Google snapped him. So, look, you say, I have a pain on the left side of my head, and I can't, buzzing in my left ear, and I, despite being a surgeon, I'm thinking, what the hell is going on? Do I have a brain tumor? What do I do? In the morning, it's still there. I take the phone, and I type this in. You know? And Google and everyone else comes up today with the AI answer. The question is, I've already given my data away, and there are billions of patients doing the same every day. So Google, you could say, is stealing your data without you even knowing. So we put this question to the Google scientist. I won't name him because, you know, it was a closed-door conversation. Google actually and big tech are taking this incredibly seriously. Be in no doubt that their governance processes are very heavy duty. And they realize that stealing the public's data, as we perceive it, is wrong, and they're not doing it, because we asked him this question. So while privacy is very, very important, every day when we wake up in the morning and type on our phones, we are giving away our data, and no one is seeking permission from it. Just keep that in mind. I think we shouldn't use data as a nasty word. We should use it for the betterment of human beings as long as it is pseudonymized and not perceived as being stolen. That's my view on data.
And I guess just to come back to your question as well about within universities, how do we get compute power and GPU access? Well, they're already large consortium. There's a very big GPU supercomputer that we're partnering with in Cambridge that we get access to. We get GPU time. So, yeah, Cambridge one. So we're part of that, as are many of the universities around that. So we do have access to that compute power. And again, the amount of power that's required is another question that needs to be addressed. But also then, you know, there's the breakthrough of DeepSeek a few weeks ago about how do you do it with less compute power. And I also think we're going to start moving, and a lot of what NITA's doing with Pharos AI is, as well as just ever expanding LLMs and assume that they're going to just give you, an inflection point, actually more curated data and sort of small and medium language models that is curated actually may be the way to go, particularly in healthcare and diagnostics. So that is an issue, but I think there are some solutions, but it's a real problem.
We also need to think about the carbon footprint of increasing data, and I think that is something we are ignoring to our detriment. The more data, you increase the cost and you increase the carbon footprint. We can't just dump it on our planet anymore.
Well, the Amazon approach and the Microsoft approach is they're investing in small modular reactors, and Microsoft a year ago took out a lease on 3 Mile Island. So nuclear waste, but low carbon. So, and it's interesting that all of the big tech companies in America, which is where they are investing in nuclear reactors, precisely for that. Indeed, exactly. Anyway, that's an interesting conversation for the bar. We have 5 minutes left, and I'm stood between you and a glass of wine or whatever delicious treats we have out there. And there was one question that I'm going to ask all of the panelists to answer in less than a minute. It's okay, don't worry, it'll be fine. And this was submitted by Jess S. I don't know if Jess S is in the room. If you are, it's a great question. And it's kind of like a summary question to the panel. And the question is, what do you think will be the most transformative capability that healthcare sees in the next 3 years as a result of AI? And so it's 3 years, so we can come back in 3 years' time for the 6th festival and see if you were right or not. So be very careful what you say, because you're accountable for this answer. I don't know who wants to start. I'm not. Pankaj, why don't you start? And so you can't say you agree with the previous panelists, okay? You have to have some. So actually, so you get the toughest jobs. I'm going to come down. 1 minute each. Go.
Okay, so for me, I think the biggest benefit from this in the next 3 years would be to reverse the aging process of human organs. And we can use AI to regenerate our own human organs using our own potential. I think that would be amazing.
Brilliant. We'll see if you're right. Anita.
Well, as a cancer researcher, for me it would be faster, cheaper, and the right treatment first for my cancer patients.
And mine is quite practical. It's simply save time to nurses, to GPs. So imagine going into a clinic, there are sensors, and straight away you get your blood levels, your heart rate, your blood pressure, all that things that can take half an hour, clean, and that will save so much time so clinicians can focus on what's important.
Fantastic. Prokar, final one.
For me, it is precision personalized surgery. Make it individualized to the patient because each of us is different. And if we personalize it to the patient, we will get better outcomes. This is already happening.
Fantastic. So we will come back to see whether you're right in the qualitative sense and the quantitative sense. And we shall see how it has shifted in a short time frame, but things seem to be going so quickly. So I'm going to draw it to a close. I think someone's going to put hopefully a QR code up on the screen. And before you go to the drinks reception, I'd just like you to put your hands together for some 4 fantastic panelists this evening. Thank you.